Okay, now we were just talking about many different ways of limiting calls. One of the things we can also do is police the RTP. So if we knew that, for example, a customer negotiated a G711 call, we should expect to see about 64 kilobits per second. If they negotiated a G729, we should expect to see 8 kilobits per second. If we're getting significantly more bandwidth than that, it can be an indication that somebody's trying to maluse your network, and we can drop the call. We can set an alarm, we can set a trap as an alarm. We can write something to a log entry. You might wind up in a scenario where you want to block some form of SIP message. We can see many down at the bottom of the page: invites, registrars, buys, infos, options, etc. You can block certain types of SIP messages if you wanted to from hitting your core network. Now, we've talked a lot about topology hiding. The SBC is going to be a point of contact for all phone calls. Those edge devices are going to be provisioned, so they're going to send in their SIP traffic to this IP address on this port. And if it comes in on that IP address and port, we can ferry it over to your application servers, to your switches, etc. So the SBC is going to completely hide all of your private topology. It's going to reside as a man in the middle with connections to the public IP addressing side and the private IP addressing side. What we see here is an example of this in this graphic. You're going to have LAN connections into the public-facing side for SIP and a LAN connection into the private network for SIP, IP, public and private. One of the big differences with this being a distributed SBC10 from the integrated SBC10, in the integrated solution, audio was handled within the session border controller itself. So you needed 4 IP addresses: public-private SIP, public-private audio, 2 public-facing IP addresses, 2 private-facing IP addresses. And those would connect in. With this being a distributed SBC, primarily the big difference is you're going to have a Q20 or a Q21 to do SIP signaling, and you're going to send the call to the Q50. The Q50 can have a lot more IP addresses and a lot more cables, because you can have multiple Q20s, Q21s sending into an individual Q50, or you could have choice number 1, Q50 number 1, choice number 2, Q50 number 2, choice number 3, Q50 number 3, so you can aggregate your audio. At a minimum, that would be 4 IP addresses, 2 for SIP traffic, 2 for audio, with potentially many, many more LAN connections in, depending on your bandwidth requirements. The point here, again, is customers hit a single address, a single point of contact. Where it goes on the back end is completely hidden from those customers. Now, denial of service attacks are somewhat interesting. We've already kind of discussed those. The big thing here is, in this particular situation, you could have a malformed packet, which could be a form of denial of service attacks. You could just have stuff sending in garbage, and again, we could identify it as garbage, and we'd have the option of blacklisting that. And again, anything that's incorrect, malformed, etc., we could just drop the packet and not route the message. So again, the SBC has blacklisting capabilities built in, and what we have the ability to do is we have the ability to look at this customer sent an invite in and it failed. They sent another invite in and it failed. They sent another invite and it failed. We can dynamically blacklist them, and we can dynamically blacklist them for a period of time and open it back up. And if the behavior repeats, we can blacklist them for a longer period of time and open it back up. And if the behavior repeats, we have the ability eventually to shut them down permanently. If you had known hacking IP addresses you were getting in your network, you could go ahead and put those in statically and then they'd have to be removed manually if you wanted to open up traffic again to that IP address range. And again, what we have here is if we detect this behavior, we basically just drop the packets from those IP addresses. We don't look at them, we don't analyze them, they just go into the bad packet bucket and they never get looked at again. And again, that could indicate malformed packets or invalid packets. So regarding call admission control, call admission control basically can limit them to a number of phone calls or a particular list of codecs used in the media resource pool. We're just going to basically look at the call volumes, the packets, the messages per second, the number of simultaneous calls, and we're going to be able to limit based on that information. A few minutes ago, we did bring this up. We could set this in different places. We had IP layer rate limiting. This is talking about total calls specifically. You're going to be able to specify total calls for a particular endpoint, for a particular group of endpoints. This can be configured at the realm level or the system level. And you could have a group of endpoints that might send in, be allowed 20 total calls at any given time, with a certain number of that being ingress and egress. We've discussed call limiting extensively here. Again, this slide is just telling us that, hey, we can look at call limits again and we can drop the call if they exceed the limits. The biggest thing is that you can configure emergency numbers in the SBC, and then emergency calls to emergency numbers are not subjected to any kind of emergency, any kind of limit. If they make an emergency call and they were limited to 20 calls, the emergency call would become the 21st call. And then as other people hung up, the emergency call would count as the 20th call. So we might not allow a 22nd call in to a non-emergency number, but if the 22nd call actually happened to be a second call to emergency numbers, we would allow both of those to go through. Now, regarding emergency calling limits, we can configure these limits based on a global setting that says, hey, is there going to be a limit to how many emergency calls I'm going to allow through above and beyond their individual call limits? Or I could assign that at a lower level to a group of endpoints, but the configuration can be done in two places. Now, if a customer is placing an emergency call, let's say they only had 5 calls up and they're allowed to be 20th, the SBC would count that 6th call as call number 6. So we would exhaust all normal levels first, and then we could exceed, if they were allowed 20 and a 21st call came in to a non-emergency number, we just disallow it. If a 21st call came into an emergency number, then we could go ahead and allow that. Now we can go ahead and encrypt the SIP signaling. So you could have edge devices that supported a cryptographic function, and you could have that completely encrypted into an application server, for example, or it could be decrypted at the SBC level. Basically, a security key has to be set in both places. The question about cryptographic methods is, are you encrypting only the payload, or are you encrypting everything? So we could be transmitting some of the header information in the clear with only the payload encrypted, or we could encrypt everything. Okay, let's go ahead and talk a little bit about fraud. Fraud in your network is going to typically occur through exploiting a user account. What do I mean by that? I would set up a premium rate service in a region, could be in your country, it could be internationally. Basically, what I would be looking to do is to trick your system into allowing me to make calls as your known good users, and allow me to call those premium rate services numbers so that I would get a check even if you never collected a dime. The customer's going to say, oh, your network's not going to be secured because you allowed this to go through. This wasn't our phones, this was a hacker, we're not going to pay you, and this is where your stop loss teams typically get involved. But what are the mechanics of fraud? Fraud, typically, if you have blacklisting turned on, you stop a lot of fraud right away. What I would do if I were trying to hack your network, I would come on your network as a known good subscriber, and I'd be sniffing the packets. And I'd say, those packets are going to this IP address. Great, I know the SIP signaling address of that SBC. And from the SIP message, I see my user credentials, my from number is telephone number at telco.com. Worst thing you can do, if you make the phone number, if you make the line port setting a combination of the user's phone number and name, you almost stop hacking this tracks. Unfortunately, telcos don't do that. They make the SIP URI, the SIP line port phone number at telco.com. Worst thing in the world. Because I come on as a hacker and I see, oh, the SIP line port is phone number at telco.com. So what am I going to do? Invite. I'm going to set up a robot program to just throw in every combination phone number in the country against your domain, and I'm looking for 1-200. Okay. What most of the time is going to happen is in the switch or the application server, you should have configured user level authentication. When you configure user level authentication, an invite comes into the switch and the switch says, stop, no, you didn't give me the shared secret. I'm going to return a response with a number once, a nonce value. This nonce value, I want you to run an MD5 checksum against this nonce with your username and password, send that back to me in a second invite. Then I will run an MD checksum on the username and password on my side, and if they match, I'm going to presume that you know the username and password. If you have authentication turned on, what can happen is the SBC will say invite, rejected, invite, rejected, invite, rejected, and if you have blacklisting turned on, we could blacklist that user. Many people don't always have blacklisting enabled. So what would happen here is I would be looking to get a 200 OK. If I get a 200 OK, I can place calls as that subscriber. So the robot program would be going invite. One passed, great, write it down, log this is a good number I can exploit. Invite, fail. Got one. What happens is your technical support team, when they're troubleshooting and customers often remove the authentication feature and they forget to turn it back on. Now, if you had blacklisting turned on, we would have seen authentication failure, authentication failure, authentication failure, authentication failure, and we would have cut that off. We would have blacklisted that user. The worst thing you can do is make your SIP line port or URI phone number at telco.com. If you make it part of the phone number, part of the last name, the rest of the phone number at telco.com, it's almost hacker-proof, because then a hacker needs to know the name of the user in conjunction with the phone number. Phone numbers are easy. Phone numbers are known. We know what the area code is. We know what the valid portions after the area code are, so they can just sit there and hammer your network. This is one of the biggest areas of loss you can get into. The other area of loss here is, again, I don't know if I'd call this a portion of fraud, but it's on a slide with fraud, so fine, it's fraud. You can limit customers to only certain type of codecs. So if their devices, they got some new super device that's capable of a lot of HD codecs and they're not buying that level of bandwidth from you, we can remove the codecs they're not allowed to have. This is created through the use of a codec profile. You can assign the codec profile to an endpoint, to a realm, to the system level. And then we would go ahead and inherit the list of codecs they were allowed to use, and we would remove any codecs they were not allowed to use from the list. I don't think, when we're talking about fraud here, we've got some bullet points on billing fraud. Basically, sometimes customers might be able to spoof some older systems by sending in invalid characters into the DNIS list. We can look for this, we can remove these SIP invites and just reject them. Or we could limit them to a particular DID range or a certain number of outbound calls, just to kind of prevent excessive call scenario situations. Now, regarding the call detail records or the billing records, the SBC is going to typically generate a CDR when user A hangs up. User A calls user B. When user A terminates that call, we would typically generate an end of call CDR. We could generate them in more places, but by default, we generate them at the end of call leg 1. So regardless of which user hung up first, the A party's leg is terminated, that by default automatically generates a CDR. With regard to telcos, I have seen a lot of different telcos all over the world, and they do a variety of different things. Some telcos bill only on the switch or application server. Some telcos collect CDRs only from the session border controller. Some telcos collect both. You may not choose to use the call detail records on the SBC for billing. Maybe you're going to get the billing records off the application server. That's fabulous. The SBC still generates billing records unless you completely disable it. There's a good reason to use the billing records. The billing records will have the release causes for the telephone call. The billing records will have the QoS measurements of audio quality for the call. They'll show the codecs that were negotiated for the call. So you have a record and you have the ability to push these to the 1EMS. This often screws up customers. They think, oh, billing records are going to the 1EMS. The 1EMS must be a billing system. It's not. It's not intended to be. That's not what I'm trying to say. We would send billing records to the billing platform if you choose to configure it, and we can send those billing records to the 1EMS. And then we can use the 1EMS to pull a report. You have a customer complaining about something. You can pull up based on source number, time of day, date range. We could see, oh yes, sir, ma'am, here are that call dropped because the other party hung up, as an example. We got a hang up message or release message from the B party. That's what terminated the call. Or you were trying to establish a call on G711 and they couldn't accept that codec. That could be an example of why the call failed. Or they had a bad quality level. We can see a MOSH score, a quality measurement, R factor. I threw out 3 different terms there. Different areas of the world use slightly different terms to mean the same thing. There is a quality level embedded into that CDR, so you can look at call quality. What we see here is party A initiates a call, the SIP invite is received into the SBC. That is considered to be call leg 1 start. The SBC is probably not going to know who they're calling. This is going to have to go to an application server. The application server will initiate an outbound call to the B party. The B party would be potentially leg 2 that might go through this SBC. It could also go somewhere completely different, a completely different SBC. But regardless, we're going to get a series of SIP signaling messages exchanged between user A and user B. And when we get 200 OKs completely around the table in both directions, the audio will be hairpinned through the session border controller or potentially through more than one SBC. But again, it's that call leg 1 end that typically generates the CDR on the application server. We do have the ability to generate a CDR for end of leg 1, end of leg 2, leg 1 start, leg 2 start. We can generate CDRs for all of the different scenarios. We do have the ability to turn on CDRs for call hunting. Call hunting might be, I was configured to go to this server, it's unavailable, I hunt to the next server on the list, so that you could have a CDR. All of a sudden, when you start seeing CDRs associated with call hunting, it can tell you one of your devices is down in the network. Now, call details records are stored locally on the SBC, And those call detail records can be configured to write a file once a day. So if I wrote a file at midnight, every new call just appends to the end of the file. New call, end of file, new call, end of file, new call, end of file. I could start new files after a certain size. Maybe I wanted a new CDR a new file holding CDRs every 30 megabytes. Or it could be a combination of time and time size. The point is there's going to be an open file for call records. Some parameter you pick is going to close those records. We will then open a new file and all new CDRs go into the new file. Now, again, CDRs can be configured to transmit via secure FTP or secure copy. And you're going to be able to send those to your billing server and to the 1EMS. This concludes this portion of this learning content. Please look for the next video in this learning series. Thank you for taking the time to view this video.